Welcome to my first virtual weather and climate office hour of 2025. Apologies if I have a little bit of a weaker voice today. I'm struggling a little bit, I think, with some sort of virus or some of the long-term medical stuff I discussed on the social media threads recently. Not quite sure which. Maybe it's a touch of both. But in any case, I'll strictly keep myself to the hour today, partly because there are going to be multiple sessions this week. So with this major high wind and fire weather threat this week, very high-end event in Southern California, likely beginning tomorrow and continuing into Thursday in some places. We'll have at least one additional live office hour closer to the peak of that threat, in addition to today's. And then also, we do have a major paper on global hydroclimate whiplash that we have been working on for several years that is also coming out on Thursday. So my goal is to have another live session on Thursday, as well as a new blog post discussing that at that point. So lots to talk about this week. The weather and the climate wait for no one. That's certainly a lesson from recent years. And I mentioned initially today that I'd have several foci of conversation. I might instead try and keep it more succinct and more closely focused on the quite serious extreme wind and fire weather threat this week in Southern California. Because that is going to affect millions of people, potentially cause some real damage, and really ramp up the threat of destructive and fast-moving wildfires. So there is some real risk to talk about this week. Just a reminder that this channel is still sponsored by Reask, a climate tech company that's helping to quantify the changing risk of extreme weather events in a warming world. Okay, so I guess the first thing I'll mention is that perhaps apropos of viral infections or not, is the widely circulating discussions, you could call them rumors or conspiracy theories, surrounding the fog. Sounds like a bad Hollywood movie, and in fact, it is a Hollywood movie from I don't know when the original movie was made. I think it was the 50s or 60s, with a remake some decades later. In any case, there are lots of rumors swirling that the fog, which has been pervasive in many parts of the country, including parts of California in recent days, weeks, and months, is somehow nefarious, beyond the usual meteorological conditions which create the fog, which, as I'll mention, as I've discussed on social media, fog is more common in winter than at most other times of year, almost everywhere in the world. That's not universally true. You're actually more likely to get fog, say, on the beaches of LA or San Francisco in May or June than you are in winter. But generally speaking, fog is something that's quite common in winter, with long, cold nights and stable atmosphere and cold, high-pressure systems. So it's not at all unusual to see extensive fog, days of fog on end, cold, clammy fog. A lot of these conspiracies and hypotheses, we'll call them hypotheses without any evidence, center on the fog causing illness, which is in fact a classic case of confusion of correlation and causation. There is, in fact, a huge surge in communicable disease right now in the U.S. Any number of things are circulating, from COVID to the usual seasonal cold viruses to influenza, including even some avian influenza apparently out there, and norovirus, the stomach bug. I can guarantee you that the fog is not causing the epidemic of norovirus, nor the epidemic of any of these other conditions. It's just that the winter season is the season of both respiratory viruses and gastrointestinal viruses, and they spread respectively through the air that we share indoors during the season when most people are spending a lot of time inside, or through the surfaces that we all share, especially in the case of those stomach bugs. So, respectively, wearing masks or being really careful about hand washing are going to help you a lot more than trying to avoid the fog. So I think that's all I'll talk about when it comes to the fog in this particular session, but just suffice it to say, if you're more interested, take a look at my recent threads on exactly how fog forms and why you should expect to see it more in winter in many places. Wish there was more fog in Southern California this week, though. That would help alleviate the fire weather threat, but alas, that fog is now long gone for a while. And that gets me to the main topic of today's conversation, which is the genuinely concerning high wind and fire weather threat in Southern California that will unfold in weak form as soon as tonight, but really won't get going till tomorrow afternoon into the early morning hours on Wednesday. And it really does look like the worst of this is going to be in the middle of the night, Tuesday night into early morning Wednesday. And it will be quite a widespread event. So this will not be like a Santa Ana wind event where it's windy in the mountains and pretty calm in the urban areas. This one is going to be a doozy. And the winds are going to reach the valleys, low elevations, even the urban cores. So even downtown LA, San Fernando Valley, these places are going to see wind gusts probably over 50 miles an hour and almost everywhere, and perhaps as high as 80 or 90 miles an hour in some cases. And if we get toward the upper end of that range, that's not only going to be posing a fire weather threat, but also posing a threat of some real substantive damage in and of itself, which is part of the concern with the most recent model update cycle. So I'll get into that in just a moment. So today I'm going to be talking about this wind event, and I also want to show, in addition to some model data, I want to get into showing some photographic evidence of mountain wave events that I have personally experienced and that other major historical ones over the years. This is really one of those examples where a very complex atmospheric process, it becomes almost intuitive if you can see photographs annotated with some arrows and pictographs. And so that's what I'll be doing in just a little while after I show some model data. But I also wanted to back up a little bit and describe why this wind event is such a great fire weather threat. Because folks in Northern California might be a bit surprised to find out that it still hasn't rained this season meaningfully in Southern California. It's been very wet north of the Golden Gate, but it's been bone dry from about Santa Barbara southward, only a few sprinkles since last season. So we're going on 9-10 months now without meaningful rain. In fact, it's been the driest start to the season on record in some parts of Southern California, also the driest 9-month period on record in some of those same places. In a season when in Northern California, we've actually seen one of the wettest starts of the season. So there are two things going on here. There's both a north-south precipitation dipole, spatially speaking, extremely wet in the north, extremely dry in the south. But there's also, and this will tie into what I'll hopefully be talking about on Thursday with that paper coming out, an episode of rather extreme precipitation or hydroclimate whiplash that's unfolded in Southern California. The sequence of events is thus. The past 2 winters in coastal Southern California were very wet. In fact, in some cases, it was either the first or second wettest consecutive pair of winters on record in coastal Southern California. But then this summer was record hot across inland areas. The fall experienced record heat across more coastal spots. And then across almost all of Southern California, the start to the season has been virtually rainless. So the whiplash from very wet, record wet in some cases, to very dry, record dry in some cases, constitutes a pretty robust wet to dry whiplash event. And the reason why that matters for fire risk right now is twofold. One is usually by this time of year it's rained at least somewhat in Southern California and fuels aren't quite as tinder dry as they are right now. But since there hasn't been meaningful rain yet in most parts of Southern California, things are exceptionally dry. And will be getting drier this week as I guess I'll call it the atmospheric blow dryer, progresses. And let me just tweak the lighting. I have some new lighting that's making me look maybe a little more pale than I actually am at the moment. There we go. There's more of a natural tone, hopefully. The atmospheric blow dryer is really going to dry things out even further, and because this is going to last several days, the vegetation will become progressively drier the longer the wind event goes on. So some of the strongest winds will be at the beginning of the event, but some of the driest vegetation will actually come at the end. And so the reality is that there's going to be a very long period of high fire risk. The main risk of serious wind damage will come in the first wave, although there will be a secondary wave of strong winds, probably not as strong as the first in most places. But ultimately, there's going to be a 3 or 4 day period with significant risk of fast-moving and destructive wildfires throughout a pretty broad swath of Southern California, and in particular, getting well outside the typical mountain areas, all the way down into the lower hills and even the valleys in some places that do not see this kind of fire threat very often. And that, of course, is where more people live. It's where there are more potential ignition sources. And it's also where it's harder to turn off the power preemptively than it is in other locations where these public safety power shutoffs are more common and are prepped for on a more regular basis. So there's going to be some potential challenges there. All right, so without further ado, I think what I'm going to do is start sharing my screen and show first some model data and then go from there. So you're going to see, as usual, the brief transition, and then you'll see the window with the model data. So I'm going to zoom in a little bit, assuming that we're seeing what we want to see. So what's the big picture here? Well, what we've got is, and actually let's see if I can get the right data for the right model here. I need a different model. All that toggling. Okay, so what we've got here, this is earlier today. So you go forward in time, you see that this low pressure in the mid-levels of the atmosphere develops essentially over Las Vegas and retrogrades, so moves southwest across the interior of Southern California and over northern Baja. In fact, it actually moves down by Wednesday to a position down over the northern Gulf of California. Not a typical position for an upper low, but there we go. What you can see is this sets up a strong contrast between the high atmospheric pressure to the north and the mid-levels of the atmosphere and the low pressure to the south. Geostrophic wind theory would tell us that the winds at upper levels of the atmosphere should probably be blowing. Let me just get my drawing tool up on the screen here, essentially in that direction as a result of that geostrophic flow. So let's see if that's actually what we find, and lo and behold, at upper levels of the atmosphere, these are jet stream level winds. That's exactly what we see. We see winds actually blowing from a very unusual direction. It might be a little bit hard to tell, but I'll illustrate it on the map here. Actually, that's not a good color. So in this box, for example, you can see that there's a jet streak, so a region of especially high winds, the purple at the center of the X, and that the winds are from northeast to southwest. So you can see that the flow is like this over California and the southwest, and that's an unusual direction. Offshore winds, of course, are usually from this direction, but in this case we actually have winds throughout the entire atmospheric column, all the way from the surface to the top of the troposphere, blowing in the same direction. And at this level, the winds are as strong as 150 knots, or nearly 170 miles an hour. So this is a very strong upper level winds. Are the winds 170 miles an hour near the ground? Thankfully, no. That's far stronger than they are. But when these strong winds aloft are in alignment with strong winds at the surface, directionally speaking, there can be a lot of transfer, more than usual transfer of momentum from these upper levels where the winds are very strong, closer to the surface. And that's exactly what we're going to see later this week. Okay, so let me zoom back in on that original model that I was showing earlier and get back into actually, you know what? I think this is probably a better way to show this. Apologies for the toggle. One more thing I actually wanted to show on this map here. These are going to be the 700 millibar winds, I believe, if I can pull that up here. I guess that's not something. So the 850 millibar winds, fine, that'll have to do here. I'm going to zoom in a little bit more. So here we are in Southern California. And I just want to point out as we go through this event, these are not winds at the surface still, but we're getting closer to the surface. These are 850 millibars. So these are the winds you'd experience, say, at the top of the mountains, at the highest mountains in the transverse ranges. These get up during the wind event all the way up into the 60 to 80 knot range sustained. Those are hurricane force sustained winds or greater at 5,000 or 6,000 feet elevation. And these will affect the surface, where the surface is 5,000 or 6,000 feet up in the air. But maybe a better way to illustrate this is to look at what the projected surface winds might actually look like. And here I'm pivoting over to a different website. So right now, let's see. So that's noon today. We're already past that. This will be 8 p.m. tonight. So this evening, of course, let's just do this. Not a whole lot of wind to speak of. It's starting to get a little breezy up in the mountains, but certainly nothing to write home about. You fast forward to overnight hours tonight. So this is 4 a.m. tonight local time. We do start to see some stronger winds, some gusts up into the 40 or 50 mile an hour range, but these are only up in the mountains. Again, that's windy, some elevated fire risk, but nothing particularly extreme. But as we get into the morning hours tomorrow, these winds will start to expand and intensify. So now up in the mountains, we're getting some gusts up above 60 miles an hour, and some of the more populated regions right along the foothills, up in the San Fernando Valley and the San Gabriel Valley, start to become noticeably windy. Just making sure this isn't Xfinity telling me that the earlier outage is coming back. Hopefully not. All right. So as we progress through the morning, again, those mountain winds intensify. We get into the afternoon tomorrow. And now even some parts of the city of LA itself, down by Riverside, start to get windy. Still nothing particularly extreme, although up in the mountains, things are getting up towards 70 miles an hour. But what I really want to illustrate is what happens in the overnight hours tomorrow night. So this is going to be Tuesday night. By 10 p.m., it's going to be windy across almost all of Southern California, except for maybe San Diego, with wind gusts 40, 50 miles an hour widespread, even in the populated metros of Orange County, LA County, Riverside County, San Bernardino County. Up in the mountains, then, we're getting 70 plus mile per hour gusts. But my main point here is that these are not going to be confined to the mountains or the usual suspects. This is going to cover most of LA County, including the city of LA itself. And watch what happens as we go overnight. Things get worse. Now we're seeing winds getting just further escalating as we get towards midnight. We're now seeing pockets of winds 70 to 80 miles an hour in the mountains. And it just keeps escalating from there as we go in the overnight hours. So at this point, there are even pockets of wind in the offshore waters at the surface gusting 60 to 70 plus miles an hour. Just along the coast of Ventura County, western LA County, so Malibu area. Up in the mountains, we're seeing increasingly strong wind gusts, but even look at downtown LA gusting into the 50s. And then potentially peaking, again, as I mentioned, in the overnight hours with offshore wind gusts up above 70 miles an hour, in the city of LA itself above 60. And here's the thing. This particular model, you can see there's certain areas that are seeing much less wind and other areas that see far greater gusts. This is likely an underestimate of the wind magnitude in some places, because this is even though this is a high resolution weather model at 3 kilometer resolution, that still can't fully resolve all of the mountainous topography of the region that can generate some of the strongest winds in a scenario like this. So I just wanted to illustrate with this, that the severe winds from in Orange County, LA County, and parts of Ventura County will be very widespread, not limited to the mountains, and could be quite violent even in some inland valley locations, or even over the coastal waters in some cases. So this is a hazard to just about everyone up through and including marine traffic tomorrow in the overnight hours. We get towards 4 a.m., there's still some very strong winds going on. Right now, it looks like these winds may shift or fade as we get towards sunrise, but still very, very windy across a wide region of Southern California, and wind shifting around event extending. Now you can see there's rather extreme wind gusts all from the Ventura County mountains all the way out toward the mountains in the deserts of southeastern California, and now also including parts of San Diego County. So this event will kind of wiggle around. The region of strongest winds will vary, but as we get into the morning, for example, downtown LA, less windy, but even stronger maximum winds up into the 80s of miles an hour in the mountains themselves. All right, so I don't want to belabor the point here too much, because I think that the magnitude of those winds that you're seeing on the map will both be over and underestimates depending on where you are, partly because there will be probably a fairly unusual situation with respect to the development of mountain wave activity in Southern California. And this is something that I don't often talk about because we don't see it too much in populated parts of California, but now I want to do a little bit of a dive into what that looks like and what are mountain waves to begin with. All right, so let's see here. I'm just going to take a quick look at what folks are asking. But I'll plan on answering questions in a more concerted effort at the end of the session here. Okay, so let me share my screen again, actually, because I have some nice graphics that I pulled out of actually the COMET modules. These are from the freely available public education modules through the National Center for Atmospheric Research. But let's talk about mountain waves, and I'm going to bring my drawing tool up once again. I believe that I'm sharing my screen, but let me just double check. Yep, there it is. So I'll bring my drawing tool back. So in this idealized diagram, you can see the mountain is here, and then there's some sloping topography down the flat. So this is the mountain labeled M. And you can kind of imagine that there are always winds blowing, often from west to east in the middle latitudes like California, in the upper atmosphere. And we know that the jet stream up high is usually stronger than the winds closer to the surface. That's pretty typical. So we have stronger winds, weaker winds, something like that. And as the air blows towards the topography, well, we know just based on intuition that air can't go through the ground, it can't go through rock and soil, so that mass is forced upward. So instead of going through the mountain, the air must go over the mountain. I feel like an exercise in prepositions. But that flow is then forced upward. That's pretty typical. But what happens with that flow once it gets forced upward like this depends a lot on the stability of the atmosphere in this region. So if there is a stable layer in this part of the atmosphere, you might get a wave that gets forced up into this region and then just kind of bounces back and forth up here. So sort of a trapped mountain wave. This is when you might see stacked lenticular clouds developing on the top of each ascending wave peak, as the upward air cools and condenses and forms a brief cloud, and then the downward air dries out as it warms and dries, and then the process continues. This is essentially a trapped mountain wave scenario where it just sort of bounces along within this waveguide. If you live down here, no worries, because there's all this turbulence going on up here, but you don't have to think too much about it living on the ground. Now, if you're a commercial pilot, you'll see my very poor drawing scales here. That's a bit more of a problem because there can be pretty extreme turbulence here. So the sort of the vomit comet ride. These days, pilots are very aware of this and try and avoid it, and airframes are almost always designed to survive even the most extreme turbulence if you accidentally enter it, but it's still advisable to stay out of it. And there are frequently injuries, by the way. This is why often pilots will tell you to keep your seatbelt fastened even if it isn't currently turbulent, because you can suddenly enter a region like this, even though they do try to avoid them. Okay, but that is not the scenario we're going to have in Southern California this week. The scenario we're going to have is similar, although you kind of have to envision this map being reversed. So this is actually the east, and this is actually the west. So it's kind of a mirror image of the real world. So imagine that these are this is the high desert essentially, and this is the coast. And the wind, as I mentioned, is flowing from northeast to southwest. So that's sort of this wind in this direction. And it's got to go up over the mountains of Southern California because it can't go through the mountains, so it's got to go over the mountains. So as you see, these follow these white streamlines. That's essentially the analogy. But in this case, this level in the atmosphere is not conducive to trapping the wave in this region. That's not happening. Instead, what's happening is we're actually getting a wave a wave that is acting or being trapped within this region here. And of course, if you live down here, now this is more of concern. So again, if you follow these streamlines, you see the air gets forced up and over, but then down. And it follows the slope of the topography. And if it's a particularly strong event, this mountain wave, and this is the mountain wave, by the way, this feature here, if it's strong enough, and the conditions are right in the ambient sense, this can make it all the way to the ground and reflect off the ground like this. And this is a feature that I'll talk about in just a moment, where you can actually get what's known as a rotor. But this is the mountain wave, and this is the main feature we're concerned about tomorrow, late tomorrow into Wednesday in the valleys, in particularly the San Fernando Valley and the San Gabriel Valley, although possibly some other regions as well. Because some of these very strong winds aloft are going to get transferred downward toward the surface to a much greater extent than would usually be the case. And this can happen in a very localized sense, by the way. So if the wind gets transferred down right here, say that's near, let's leave that, say that's near Pasadena or something, if you're in an adjacent region here, the winds could be almost calm as the winds sort of bounce back up and reflect. But then they might be really strong again right here. So there'll be strong variation from place to place in where this wind is occurring. And I mentioned I was going to talk about this, but I actually have a better diagram for that. So here's a zoomed in version of that figure. This is the rotor. Let me just, and you can kind of see how this forms. If you have movement like this, and then this, and then this, you can kind of see how there's a sense of rotation like this in this region. And it literally is meant in the vertical sense. You actually do have upward motion here, downward motion here, reverse flow here, and flow like that. So you actually end up having flow aloft that matches the mean flow. And in a particularly dramatic rotor, you can actually have contralateral flow. So you have wind at the surface here, you have wind at the surface here, but in these regions of convergence, you actually have wind that are quite chaotic. and you can get all sorts of little curly-Q spins, and this is why do not fly here if you're a pilot. But of course, that's old hat to anybody who's actually a pilot. But anyway, the most consistently dangerous winds are in this region, in the terrain following right down to the base of the valley down here. But they can persist in a particularly strong event for this entire region, and this is the concern regarding the San Fernando Valley and the San Gabriel Valleys in particular, because this is a strong enough event that this zone may extend all the way across them. And then there may be, at some point, a jump. The jump region, you actually have a local minimum, so you might actually see, you might be A-OK there. But then again, downwind, you have some problems. This can result in some really dramatic phenomena. So you might imagine, okay, if there were tracers in the air, dust or smoke, you might see the smoke do something like this and do that. And in fact, I'm about to show you that that's exactly what it looks like when that happens. So here is a particularly, let's see here. Oh, I didn't, here it is. Okay, this is what I wanted to show. This is an pretty incredible photo. This is from California in December 1977. This is the Great Dust Storm, Bakersfield Dust Storm of December 1977. This is a photograph taken by, wow, that's pretty amazing. I just happened to superimpose that exact image on this photo, and it works so well. I'm not even going to change that. So this was entirely by accident, by the way. I just brought that graphic back up, and it literally matches the physical process that's going on here. This was a major downslope windstorm that created a really incredibly destructive dust storm in the southern San Joaquin Valley during exactly one of these wind events. So this is essentially from east to west. So this would be the Sierra Nevada, and then these would be this is the Central Valley. So Bakersfield is in the middle of the cloud. But you can see this downslope flow. It really is kind of amazing how that worked out. Speaking of the theory becoming real, that is exactly what you're seeing in this image. You're seeing this downslope windstorm down here, very extreme winds in this region, in some cases up to 100 miles an hour. And then here's the hydraulic jump. It literally looks like water that you might see, for example, in a stream, in turbulent whitewater. But you can see this play out because, again, as always, the atmosphere is a fluid. Remarkably, I believe the photo credit back in '77 goes to Sam Chase, who I think was a U.S. Geological Survey employee at the time. But in any case, a really striking example, and I'll just show the raw version of this again before briefly redrawing it. Here's the downslope mountain windstorm, and here is the hydraulic jump, where the dust is just jumping up into the air thousands of feet and then redescending and being deposited. There was so much dust that got deposited here, by the way, that it filled up freeway underpasses, not with water, but with dirt. And this storm did kill people and caused very extensive damage in the San Joaquin Valley. So this is a particularly extreme example, but it is something somewhat analogous to what we could see in Southern California this week. Now, there's not as much dust, so we're not going to have the same level of dust storm. But the other major concern is fire, and these sorts of severe downslope windstorms characterized by a strong mountain wave and then a subsequent hydraulic jump have been associated with some of the most destructive recent urban interface wildfires in the U.S. and globally. This includes any number of wildfires just in the past 5 years. So thinking about the Marshall Fire in Colorado in December of 2021, or more recently, the fire that destroyed the community of Lahaina on Maui. Exactly the same thing. There's photographic evidence of both of those. Same as major wildfires in Southern Europe and Australia and Chile, Canada. This is identified. This is really something that often coincides. Now, of course, you can get this downslope windstorm, but if the vegetation is moist to begin with, you don't get a fire because it's not dry enough to burn. But this is where there's a big problem that we've seen a record dry start to the rainy season in Southern California. That's why the confluence is particularly concerning. Okay, so some of these got deleted, so I'm going to have to sorry, just gotta, here we go. Okay, I'll just bring them up from here instead because this is probably faster. So you're seeing my very cluttered desktop at the moment. These were photos that I took during the Marshall Fire event in December 2021 in Boulder, Colorado, or near Boulder, affecting primarily the community of Superior, directly to the south of Boulder. But I just want to show some of these photographs because these illustrate pretty dramatically the effects of what happens when there's a wildfire that develops under breaking mountain wave conditions. So just let me get my drawing tool all set up here. So this was the first photograph I took of the day. I was out and about, and now out and about's a relative term. The winds on this day were ridiculous. They were very, very erratic, very gusty, sometimes as light as 20 or 30 miles an hour, but occasionally gusting to 100 miles an hour. Now, at the moment I took this picture was in one of those lulls. But this is west again. Let me keep the marker. This is west, and this is east. And in this case, the mountains are to the west. So the mountains are here in this photo. The plains are in this direction. The downslope windstorm was going like this, and then the hydraulic jump literally is here. So you can actually see these very strong winds in this region. This is where they were like 100, literally gusting to 100 miles an hour. The fire developed right in this region. It moved into this region. The fire itself is generating a pyrocumulus cloud here. And this is the hydraulic jump. You can see the upper level cirrus is getting pulled this way, and then the smoke is then falling out this way. So here is your hydraulic jump. And the fire pretty much was unstoppable until it reached the point where the winds weakened right around here. So the fire moved all the way across the horizon like that. But I have a couple other photos I want to show because these show the slightly later progression. And let's see. This is the same event again, the Marshall Fire, taken again from the perspective of, and this is west. Let me get this to stick. This is west. This is east. Again, plains are here. Mountains are over here. But this is in the middle of the downslope windstorm. So this is when the winds are going like this across the screen. And when I took this, I had to brace myself on the upwind side of a tree because the winds were about 100 miles per hour when I took this photo. And as you can see, this is just this fire is just sheeting across the landscape, moving just at an incredible speed. At this point, it had just jumped over a 6-lane highway, which is actually right about there. But you could feel the ebbs and the gusts. I mentioned the gusts were 100 miles an hour about that when I took this, but there were moments where it was just a light breeze, 20, 25 miles an hour, and then this 100-mile-an-hour gust would come. You'd actually see the fire almost self-extinguish for moments during the 100 miles an hour gust because there was almost too much oxygen. But in the moments in between gusts, the fire would flare up like this. There'd be a lot of flames, but in those very strong, even though the flames themselves didn't look as dramatic during the strong wind gusts, that's when you were getting these embers being carried from pocket of fire to pocket of fire, and you start to see this very rapid forward progression of the fire through the ember storm. So not through the contiguous flame fronts like this, but through these showers of billions of embers getting lofted and just jumping over themselves and continuing on for several miles. This is, again, this is a specific example, but this is what we've seen with so many fires. It's the discontinuous spread that's often even more consequential. And then finally, what we see, and this is the last photo I'll show from this event. This is again taken from looking, essentially from, let me just get this back on the screen. This is again west to east with mountains and plains. this is maybe the best encapsulated view of the mountain wave. At this point, it's just flatline winds coming, and you can literally trace the rotor here. This is approximately where the winds died down to zero. So at this moment, there were winds gusting to 100 miles an hour in this region, and gusting to about 20 right over here. So the fire is just getting pushed like this. It's burning intensely here because there's good ventilation. There's a plume-dominated fire. The fire was essentially unstoppable in this region because the winds were pushing it. Interestingly, and I'll draw this, just one last piece of drawing. Again, the winds in this region at the surface are like this. The winds here are doing this. They're doing that over here. Amazingly, the winds were actually doing this over here. So there was weak inflow winds converging right around here, creating a bit of a chimney effect and sort of influencing the high intensity of the fire here. This was superior, and a lot of the town burned during this event. So suffice it to say, these are the kinds of dynamics where meteorology and fire dynamics converge, and this is the kind of pattern that we're potentially going to see this week. I will mention that in December 2021 here in Colorado, conditions were record dry leading up to this wind event. And the wind event itself was not unprecedented. We'd seen wind events like this before, although unusual, certainly not unprecedented in this part of the world, just as this upcoming wind event in Southern California is not unprecedented for Southern California. It will be a high-end event, but it's nothing that hasn't occurred before historically. However, this event will likely be greater than the sum of its parts in the sense that we really haven't seen a season as dry as this one follow a season as wet as the previous one, with all of that extra abundant growth of grass and vegetation followed immediately by a wind event of this magnitude while it's still so incredibly dry. Okay, so I will go back. You'll see my face on screen again momentarily. One thing I want to point out is that there will likely be pretty significant day-to-day disruptions from this weather event in Southern California. In fact, this will probably affect more people more substantively than a major rainstorm in many ways. Certain roads will be closed to public access to prevent potential fire ignitions. Hundreds of thousands, if not perhaps over 1 million people, could end up seeing power outages through a combination of preemptive safety shutoffs by the utilities to reduce risk, or actual unintended power outages because the winds themselves will be pretty damaging in places that don't normally experience it. There will be a lot of downed trees, hopefully not too many downed power lines, but that's a real risk, and that's why the power will be turned off preemptively in some areas. So all in all, a pretty challenging situation for Southern California. My hope is that there are few, if any, ignitions of note. We know that not all fires are bad. In fact, we need more fire on the landscape in the long run in many areas rather than less. However, these are not the kind of conditions under which we want to see those fires. So I think it's fair to say that in Southern California this week, forward from this moment through at least the weekend, just about any wildfire ignition is an unwanted one that could cause a lot more harm than the benefits it could provide under other circumstances, and so I think it's a good idea for everyone to try and avoid any ignitions that they can. The problem is, in a modern world, we're sort of ignition saturated. In the modern world, anything that relies on electricity or combustion or batteries has the potential to produce sparks, and despite your best attempts to prevent them, sometimes things go wrong. Sometimes someone's water heater catches on fire, or their lithium battery and their e-bike could catch on fire. You mitigate as much as you can. You try and avoid people doing stupid things or reckless things, and you mitigate the mitigatable risks. That's what the electrical utilities are doing in events like this by turning off the power. You know that strong winds could potentially blow down power lines, blow down trees into power lines, cause sparks and therefore fire. One challenge I'm seeing in this case is that here the utilities are more used to doing public safety shutoffs in the traditional high-risk wind corridors. it's old hat for them at this point in those areas. This event is going to see very high winds and very high fire risk extend to lower elevations and more densely populated areas. The cost-benefit analysis of shutting off the power preemptively is trickier there, and I'm not sure that all the utilities have fully established the same level of standardization and outage blocks and notification for all of those lower elevation and more densely populated areas. So I don't really know what to expect, except that there will likely be widespread public safety outages as well as additional unplanned outages from actual utility damage. My hope is that at least we can avoid major fires, but I am personally pretty concerned that there will be at least one or two very fast-moving, dangerous urban interface fires this week in Southern California. I think it would be difficult to avoid seeing any of those. I hope that they are as minimally destructive as possible and that everyone is prepared and gets out of harm's way. But this is one of those patterns that makes the hair stand up a little bit. So the great irony, of course, is that in Northern California, there's essentially zero risk to speak of. And that's another point I wanted to make. California is a big state. The conditions right now are completely different north of San Francisco than they are in Southern California. There is virtually zero risk of a dangerous wildfire in Northern California. It's just too damp. That's the good news. In fact, Northern California will benefit from a period of finally sunny and drier conditions after a very wet spell. But that is not the case in Southern California, where conditions have been bone dry. The fire risk is going to be extremely high, and this will be one of the largest fire risk events we've seen in recent years, which again is saying something. So my plan, by the way, is to have another live stream on this. I haven't yet fully decided exactly what time. It could conceivably be late tomorrow, but more likely early Wednesday, so probably Wednesday morning. I'll have a live stream to follow up. I'll update on social media when that'll be. And then, of course, if anything happens, the most dangerous period in terms of the coincidence between the strongest winds in the most populated areas, it is unfortunately going to be in the middle of the night, Tuesday night into early Wednesday morning. So that is the period during which I would pay the closest attention. As you know, I'm increasingly a fan of watch duty. In fact, I've had a conversation with the CEO recently. I'll probably be working with them to further develop some of the risk visualization aspects of that really helpful tool in this space. It is really accessible. The free version of it is actually gets you almost everything you'd want to know in a wildfire emergency. So I'm personally pretty impressed by it. I will be keeping track of anything that breaks out that way, as well as via social media. But also there are insights that you can't still get even from that sophisticated level of technology. For example, information in real time from weather radar and satellite imagery, which can be difficult to interpret. I'll be talking about that as it develops, hopefully not as fires develop, but at least as the winds develop, and then perhaps if there are fires, looking at that as well. And you'll see me again later this week for another live session, hopefully not fire related to our paper. But again, there's a nexus here in that Southern California is experiencing a rather extreme wet to dry hydroclimate whiplash event, and that is the subject of our forthcoming paper that I'll be talking about later this week, and also with a new blog post on Thursday as well. So I would like to take a look at the comments. I promised myself I'd keep it to an hour, but that still gives us 10 minutes for comments. So just give me a moment to sip some tea, and then I'm going to be reading down the list of the chat. Yes, as many people point out, because of these power outages, this is a good opportunity to make sure that by 5 or 6 p.m. tomorrow that all of your electronic devices are charged, your backup chargers, your battery packs. Good time to move vehicles and sensitive, fragile objects outside of the corridor of wind or places where they could fall. And probably not a good night to go for an evening stroll in the park under trees that could fall or have branches that come down. Unfortunately, that has been a pretty common cause of injury and death during major windstorms in California in recent years. So it is I know it's interesting to go out and look at things, but if you do so, don't get in the way of emergency responders, and also really pay attention to what is either above you or what could blow into you from upwind. That's the other piece, the other hazard in an event like this. Yeah, Steve mentions there was I mentioned the movie The Fog earlier. There's a John Carpenter remake in 1980. I think there's also a more contemporary one sometime in the 2000s, as well as the original one earlier. But in any case, it ain't the fog that's causing norovirus. Go wash your hands. Uh, Question from Mark. Breaking mountain waves, hydraulic jumps, rotors. Are these terms synonyms? Causally related? Causally related? Yes, they are causally related. As I mentioned, they're not synonyms necessarily, as I showed earlier. But these are all related terms we don't often have to think about a lot in California, but when they do occur, they can produce really high impact weather. By the way, I mentioned the hazards to aviation. I would expect numerous flight delays, if not cancellations, this week, particularly later tomorrow into Wednesday. And this could include LIX, Burbank, Ontario, and also some of the smaller regional airports. So pretty, again, if you fly a plane through some of these mountain waves, you don't want them. You don't want to be there. You don't want to be there as a pilot. You don't want to be taking that responsibility for your passengers. And as a passenger, you don't want that experience. You can trust me on that one. Best case scenario is the air sickness bags get a lot of use. Worst case scenario is considerably worse than that. And so airlines are aware of this, and pilots are aware of this, and so they will rather restrict the flow of flights or cancel them entirely or reroute them so that they can avoid the worst of the turbulence in these mountain wave. In particular, speaking of rotors, it is in particular rotors that are especially dangerous. As you can imagine, the worst thing that can happen, one of the worst things that can happen in an aircraft, is to be forced toward the ground by downward rushing air unexpectedly, and to experience sudden wind shear, so sudden changes in the direction or speed of wind. And in this kind of pattern, you can get both of those things. You especially don't want it to happen when you're on final approach or just after you've taken off. So when you're close to the ground, you don't have as much maneuverability. You lose a couple thousand feet of altitude in a mountain wave event at 30,000 feet, and it's a very uncomfortable and scary experience, and the plane is fine. You lose a couple thousand feet of altitude on final approach, and that's a whole different story. This used to be a relatively common cause of airline, even commercial airline crashes, actually, as recently as the 1970s and 1980s. But due to meteorological advances, it almost never happens anymore because there is instrumentation and forecasting that either allows individual planes to avoid landing or taking off under those conditions, or proactive weather forecasting that just prevents flights from being scheduled during those periods or on those routes to begin with. There's a question from Dana. Is it accurate that the wind event could increase spread of valley fever? Would N95 or comparable be productive? This is actually something I have a collaboration with, actually multiple collaborations with colleagues regarding climate and the causative fungal organism that results in the disease known as valley fever, which is becoming much more prevalent in California, possibly due to climate change and other factors. There's still some loose threads there. The public health advice is surprisingly mixed on this front, but in general, I would wear something, if I were in a dust storm, and in fact I've done this before, I would usually wear protective eyewear and something like an N95 mask as suggested, solely because I don't even want to breathe in the dust, let alone whatever pathogens may or may not be transmissible in the dust. You also don't want to breathe the dust, or if there's fires, the wildfire smoke. So I have very dry eyes, so I keep the eye protection on anyway. But I would also wear a mask. I think if you're in a visibly dusty or smoky environment, that's almost always good practice. So I'm just scrolling down the comments here, trying to get through as many of them as possible. Lots of questions if I'll be able to look at other regions. Not at this time, not in this session here. Bob asks, PV here, should I avoid cycling tomorrow? I'm assuming PV, maybe Palo Verdes. Well, if you can get it in early, maybe that's all right. The morning should be okay, but if you're planning going for an evening ride, probably not a good idea. There will be some major winds in the Sierra and downwind of them as well. They're less rare there. Mountain wave events are more common. They can still be destructive sometimes. I have frankly not taken a closer look. The only good news is that in most of the Sierra, it's too damp for the fire risk to be really high. That's not 100% true. There's the far southern reaches of the southern Sierra, maybe including the Owens Valley, just to the east of this. There could be some wind-driven fire risk because once you get strong enough winds, even some precipitation isn't enough to fully mitigate the risk. But I'm really 95% of my concern due to both where the vegetation is driest, where the winds are going to be strongest, and where the most people live is pretty much Ventura, Los Angeles, and Orange counties, and some carryover into the portions of adjacent counties this week, and in particular late tomorrow afternoon through about noon Wednesday. Although the threat will continue through Thursday or Friday, there could be a second wave of winds. Even though the winds might be weaker, it'll be warmer and drier with the second wave. And there could be yet more offshore winds next week with no rain in between. So this could be playing out all over again. Fog Machine asks, one of the models has a 1030 millibar high near Palmdale and a 1018 millibar near Catalina Island. So essentially a pressure differential of about 12 millibars over that distance. Is that not enough for such a strong downslope event? Ordinarily, no. That's only a moderately strong surface pressure gradient, but in this case, it's not really the surface pressure gradient that's so anomalous. It's the winds aloft, and the pressure gradient or the geopotential height gradient at upper elevations combined with that very strong geostrophic wind, so that jet stream in alignment with the lower levels. So this is an event that's very much greater, as I mentioned, than the sum of its parts. I would expect to see much stronger winds mixing down to valley areas locally in these mountain wave events than is usually the case, and I hope it doesn't happen, but there's a slight chance of seeing winds even excess of 80 or 90 miles an hour in a few isolated valley locations. Sometimes we see that with some regularity on the mountaintops, but I would not be too surprised to see local, almost like that. They aren't technically microburst conditions because it's not being caused by a thunderstorm, but almost a similar effect with very strong localized winds with a strong downward component to them wreaking havoc locally. Those can be quite damaging, and I would not be surprised to see some highly populated valley areas, granted relatively small regions, but substantially populated ones, see isolated gusts to 80, 90 miles an hour like that. And that, again, if there's a fire under those conditions, yikes, right? Yeah, so there's not really much evidence that climate change has increased or decreased the magnitude or likelihood of the wind events themselves in Southern California, but what there is evidence of, and especially moving forward in the future, is that the climate change is increasing the overlap between extremely dry vegetation conditions later in the season and the occurrence of these wind events. Because, of course, if we'd gotten 3 or 4 inches of rain before, the week before this event or something, we wouldn't really be talking about the wildfire risk. We're talking about the wind damage potential still, but we wouldn't be so worried about fires. So it is that confluence of seasonal hydroclimate and the winds. There is evidence that climate change has already affected and will continue to accentuate changes in seasonal hydroclimate, but not so much evidence it's really affecting the winds themselves. or that it will necessarily in the future. There's one point, commenter Void asks, do you know why the models are showing lower wind amounts for the lower parts of the inland empire? Is this due to the terrain or model inaccuracy? I think both, depending on which model you're talking about. I wouldn't take the models too literally. I also wouldn't take automated weather apps very literally during this event. They simply cannot capture the highly fine-scale details that are critical for understanding the specific spatial patterns of winds. As I mentioned, this could be a case where some localized near sea level locations could see 70 or 80 mile an hour wind gusts, and 2 miles away there could be a gentle breeze from the opposite direction. Very erratic, three-dimensional swirling wind motions, difficult, if impossible, for models to represent directly. So this is where human meteorology really comes into play. It's difficult, if impossible, to pinpoint exactly where that's going to occur, but it does look like some places all the way down to sea level will see very strong winds in this event. Not everyone. There will be people who call it a bust and don't get big winds, but count your lucky chickens. I guess that means something different in an era of bird flu. But anyway, other places will not be so lucky. And my only real hope is that we don't have a major series of wildfire ignitions. That's the part that is controllable because, of course, essentially any plausible ignition in this environment is going to be human-caused, either accidentally or otherwise, because there really aren't any natural sources of fire ignition under these conditions right now. There's no lightning out there. There's no volcanic eruptions, short of a very bizarre concatenation of Rube Goldberg-like events with a rock slide or something. There just aren't really a lot of ways for the natural world to make sparks under these conditions, and yet there's an abundance of sparks just through the realities of modern life. And so that's why there's so much concern that there probably will be at least a handful of ignitions. The question is whether they take off or not in this extreme risk environment. Oh yes, nobody wants to talk about earthquakes. Yeah, I'm not even going to go there. You're right that, that's, I suppose, the one thing that could generate additional ignitions that would be natural. The ignitions from an earthquake, by the way, potential fires, are still human caused, but that would be indeed be a whole different can of worms. All right. Well, I'm going to keep it. I'm going to call it. Thanks, everybody, for joining. As I mentioned, I'm going to have at least one more live session this week, if I can manage it, on this event. Time and date TBD. It's going to probably overlap with this period of stronger winds, and as much as I hate to say it, probably at least a fire or two that I'll be tracking in real time. I'll be all over it on social media. Watch duty is a great way to keep track of the fires. There's some weather information there right now, not as much as I would like to see in the future, but it's at this point, I don't think there's any more efficient tool to find out whether there's a fire close to you and what's going on with it in real time and reliably, so I do recommend it for that quite strongly. I'll be following the weather. This is an event that could actually be dangerous just from a wind perspective. So if you are in one of those unlucky valley locations that gets those 80 to 90 plus mile an hour mountain wave localized downburst-like gusts, you could have broken windows, even trees coming down. So this is something that if it does get that bad, obviously, be careful. Be mindful of what's above you, what could blow into you, and just don't do anything that creates sparks. Just don't do it. Just wait a day or two. That's all you got to do. All right. Talk to everybody later. Thanks for joining. And as always, this was recorded live and will be available momentarily once I push the stop button. And I will see you next time. You can check out my most recent blog post on weatherwest.com that discusses this. And then we'll have another blog post later this week discussing our forthcoming paper, all too relevant paper on increasing hydroclimate whiplash on a warming Earth. Stay safe out there, don't create any sparks, and I'll check in with you